Hello, my name is Xu Yixing. My contribution to the Lab 1 is helping my teammate understanding the overall architecture about the x86, letting them know what files we need to add. The architecture of the system call is shown in the image. The general process is that perform left-test.c file to call the system call. It will use the user.h as a bridge to go into the kernel mode and trigger the system call function, which is registered in the system call.h. After that, system call.c will invoke the function in sysproct.c, where the actual function is. It executes the specific system call logic and return the result to the top level. And result will be returned level by level to the top and be stored in the track frame in the last, with which the user could get the result from the kernel. After this step, the whole function call process will be finished.
Hello, TA. Based on my teammates' architecture, I have implemented the system info system call. It has three functionalities. Firstly, it counts the active processes in the whole system, and secondly, it counts the total system calls in the current system, and thirdly, it counts the free memory pages in the current system. I have already write the detailed implementation in the report, and I do a detailed test, which is match the requirement of our project.
Hey there, my name is Rehan Nani and I implemented the part 2 for the lab assignment 1. For implementation of the proc info, we added two new fields, system call count and page users, added to the process structure. This allows tracking of the specific state for each process instances. After that, in the system call function, the current process instance is accessed and the system call count property is implemented. This records the system call count for each process. Now accessing the memory during fork, the page users property is assigned to the parent memory. When a process is created using fork function, this ensures that the correct system call count and page users are recorded for each process. Returning results with proc info system call. The copy out API is used to copy the current process states from the kernel to user pointer, allowing the user to access information about the current process in the kernel. And lastly, the test and validations. Test for the proc info shows that implementation is accurate with created process IDs, current ID, system counts, and page users aligning with the expectations. I guess that is it.
Okay, here I will show the demo from the beginning. Here we firstly to log in the server, because I use the server to do the project. Okay, we have a login server, so we go to the project folder, and then we must source the environment. Okay, and then we use make. So here it will process the making process. Okay, it says our kernel is booting, so we can go to the text file. We assign this size, memory, and two child process. Okay, here shows the result. So firstly, the system have three initial processes, and this size free page. And after we assign some memories, it decreases to this size. It is fair because it's 17 pages, and each page is 4 KB, so it matches these bytes. So and then we fork two processes, child processes. So this is a child process ID, and the page uses is same because they have the same parent ID. So they will use the same parent memory, because that is the principle of our fork. And then we call system function, info function, the system call gain. It says we have 5 processes. Yeah, that is fair. So this is the code 3 pages. So that's all. Thank you.